I haven't done this talk before because I wanted to focus a little bit on the oceans, that being a theme tonight, coral reefs, etc. So we're sort of going to talk a little bit about science and oceans and my sort of the way in which Conservation International and how I think about conservation for the future. So to start with, I was born on an island. And it's Sri Lanka, right? Small island in the middle of the Indian Ocean. And when I was born, my grandmother took me to an astrologer. And the astrologers at the temple, they don't read your palms in Sri Lanka. They read your hair, the pattern of growth on your hair, the cowlicks, if you will. And I had two, and they went in weird patterns. And my grandmother comes back, and in a hushed voice announces to the whole family, she's the matriarch, that I would die by drowning. Now, if you're born on an island, you're kind of screwed. So this is what my parents did to me. I was locked behind bars, and I could look over. Notice the artful placing of the hands. I kind of keep wondering about what I was thinking there. But I could look at the ocean. I was taken to the ocean, but I was never allowed to swim. And that was the way it was, really, yes, really, it was true, until I was about 9 years old. When my mother, who doesn't really particularly swim well herself, broke with tradition and taught me how to swim. And that completely changed my life. I've swum in every ocean, done shows on television with diving with things like this. This is the untraditional way of catching a shark, which is try to grab it from the non-pointy end and then hang on for dear life. And it's just changed my perception of the world. Now, why am I telling you this? I'm telling you this because in some ways, to me, it's like an allegory. You know, it's a bit of a story about where we are with the planet, about the environmental movement. If I went through this audience and told any of you that you or your child or something like that would die by drowning, and then I asked you, would you want to learn how to swim? Would you want to teach your kid how to swim? I bet all of you would say yes. Yet it's not the logical thing to do. The logical thing to do is what my parents did the first 9 years, which is they didn't even let me take a bath. Water in buckets was hoisted upon me, but I was never allowed to immerse myself in water, right? That would be the logical thing. Keep away from water and you're fine. But yet, that's the human spirit. It's not about what the future foretells. It's about really what we do about it. This is the largest body of fresh water, the fourth largest body of fresh water on the planet when I was a child. It's the Aral Sea in Uzbekistan, the border between Uzbekistan and Kazakhstan. And think about it, the fourth largest body of water, fresh water. And in our lifetime, it kind of looks like this now. And in Uzbekistan, it's virtually all gone. If you go to Uzbekistan, which I've done, you'll go to a little town called Monyak. You'll go secretly because the government doesn't really like you going there too often. And you will see an entire fleet of fishing boats. They used to bring about 10,000 tons of fish into the harbors every single year. Today, they look like beached whales. And to get to the water from this point, you have to go about 150 kilometers, driving straight through the desert for about 5 hours. And you'll eventually run into a sliver of water, which is so saline that nothing bigger than brine shrimp can live in it. No vertebrates can live in it. It's so hypersaline. And this entire industry, this entire city is gone. And it's sometimes called largest man-made disaster still, sort of on the planet. You can see it from space, et cetera, et cetera. And all the stuff I'm standing on, it's actually fish bones and shells. It's not sand. It's a pretty remarkable place to go to. And you think this happened on my watch. So when I was a child, those boats would have been about 20 meters above my head, floating on a blue inland lake. And just in case you think this is far, far away, then just think about what's going on with the Colorado River. The Colorado River in the Grand Canyon is this massive river. By the time it crosses the border to Mexico at the Morales Dam, only 10% of it's getting into Mexico. And then you go another few kilometers into there, which I have done, and you can stop the Colorado River with your foot. You can literally dam the river. And it dies about 100 kilometers from the sea. And since 1998, not a drop of that water has actually reached the sea. So we are doing this, and I don't need to go into the sort of different ways in which we are harming our planet. I'm really here to tell you about how, at least in one area, we might escape some of those predictions about the fate of our planet. I'm going to show you a little film clip to bring us to oceans that I filmed for a series called Earth and New Wild. And it's me talking to an ocean scientist, a fishery scientist by the name of Jeremy Jackson, who is from Scripps University. He's sort of the godfather in some ways of the role that big predators like sharks play in the oceans. And just watch this clip and I'll just make the issues in the oceans revelatory to you. Okay, before I go there, I guess I'm going to tell you this first. So what I'm going to do, so after I do the film clip, I'm going to come back to my talk, which really is going to focus on 3 areas: science, people, and business. You need science because you need science in order to explore the oceans. There's still so much we don't know about when it comes to the oceans. You need people and communities because at the end of the day, they're the stakeholders, they're the ones who will protect it. And then you need businesses, because any great idea, if you want to scale it, you have to either use government, which is slow, or businesses, which tend to be fast. Okay? Now let's see. Okay, here we go.
If you fell off this 100 years ago, there would be a very high probability of a shark attack. And there would have been 500 6-foot sharks swimming around. That would not be a really cool place to jump into the water.
Dr. Jeremy Jackson is considered one of the world's leading ocean scientists. He has spent his life analyzing data that reveals the full story of our human relationship with the sea. Over a cold beer, Jackson tells me there's one factor that really stands out in explaining what changed our oceans: overfishing. And to convince me, he's brought along an unusual bit of evidence.
So these are a series of pictures that started out from the work of
Photographs taken right here in Florida across the decades, showing sports fishermen with their catch. Same dock, same season, same ocean, but very different fish.
I mean, there's just no way that one can misinterpret what's happened here, which is that we've eaten all of these, and then we've eaten all of these, and now all we have left is these. So these are just emblematic of a panoply of gigantic creatures that used to live here.
So once upon a time, the oceans had monsters. Today, it's down to shrimp.
Today it's down to shrimp and clams and squid and whatever, and that is what's going on in the ocean today. The way it all works is it used to be good, whatever that meant. And now we're out here someplace, and over here is the apocalypse. Forget it, end of story. We know we don't want to go there. We've finally woken up to the fact that this is not a good thing. We are nostalgic about this.
But we're not going to get back to
here,
are
we will never get there. Maybe we'll end up here or we'll end up down here, but it won't be the way it was here. But it'll be a hell of a lot better than there or there. And if I can have a totally artificial ecosystem, which has a significant component of the species that do different jobs, well then, that's great, and I'd be happy with that.
Is that the reality of nature or wilderness in a world with 7 to 9 billion people?
That's right.
So he is known as Dr. Doom. That is actually his nickname in science. And you spend a little time with him and you actually want to jump off the dock. But he's a really bright guy, and it was insightful being and spending time with him. So now I want to sort of go into these 3 areas that I think are sort of critical for us to understand and then better manage the oceans, especially as we think about fisheries. So the first thing I want to talk to you about is science. So what's really exciting when it comes to science today is that we can do 3 things that we really couldn't even imagine doing a decade ago, certainly not 2 decades ago. The first is we're really getting a great understanding of the really, really small, right? At the molecular level, at the DNA level, we're getting really, really good at detecting small things and sort of splitting down into the smallest parts of the biology of something. And that's important for lots of things. we're getting very good at being able to map and see the ocean, see the whole ocean at once from space, or do autonomous mapping at very large scales. And that level of discovery is really kind of neat because it's the first time we're discovering a new continent, an underwater continent, but without humans literally going there and mapping it. We're doing it autonomously. And the third thing is we're getting really good at figuring out the big, the very, very big. And that very, very big part is the one I want to just focus on just for a minute here today, because it's fascinating, right? So the ocean is so opaque, and even when you live on an island, you just only see that veneer on top. But it's all the stuff that goes underneath that is so fascinating. And now we're actually able to tell you where things go, big things go, where tuna go, where whales go, where sharks go. And that's showing us this whole new level of pattern and movement in the oceans that when I was in grad school would have been impossible to think about. So let me see if I can show you a little film clip that sort of illustrates that.
This tuna fishing boat is homing in on its target. It's been sailing for weeks off the coast of Papua New Guinea to find it. These yellow-fin tuna are crossing the Pacific Ocean. Some tuna will travel 12,000 miles in a year. Unlike most fish, they're warm-blooded, which enables them to get more heat to their muscle and generate more power and speed. Making them one of the ocean's top predators. Today, there just aren't that many populations of migrating tuna left on Earth. These fishermen are heading right into a huge school. You might think this is the tuna's last gasp. But this is just a brief trip into our strange human world. These tuna aren't being killed, but fitted with a tracking device, and then released to continue their migration.
We've been tagging fish everywhere from Indonesia, Philippines in the west, through to Hawaii, Kiribati, Marshall Islands in the east. Since we started in 2006, almost 400,000 fish have been tagged, 65,000 of which have been recaptured so far. That's about 17%, and of course more is still coming in.
This tuna tagging is part of a global effort to understand the movement of ocean predators. Scientists have tagged tens of thousands. They've gathered 300,000 days worth of data and counting. Individual animals can now have their profiles followed globally. It's like a Facebook for fish. These predators also reveal where the other fish, their prey, congregate. All this data builds a remarkable living map of the ocean to help us pinpoint the parts that matter most.
So that gives you a sense of how we are starting to really understand patterns in the ocean at really big scales. Another area that we are getting good at figuring out where fish go. What about fishermen? So I want to show you a part of the world that is one of my favorite parts of the world. It's a country called the Republic of Kiribati. It's a small island nation, but it's a gigantic ocean nation. If you look at Kiribati from end to end, it's about 2,000 miles from end to end. And a few years ago, Kiribati did something extraordinary. They took a big chunk of the ocean where tuna go for breeding, and they set it aside. They said no more tuna fisheries for at least a decade, maybe more. And that's the area in the middle, that square right there. It's called the Phoenix Islands Protected Area. And this giant swath of ocean is about the size of California. It's significant. It's really, really big protected area, specifically for tuna. Now, how do we enforce this? How do we figure out who's fishing there and who isn't? Kiribati is so big and so wide that the president of Kiribati, if he's trying to travel from one end of his country to the other, he has to actually fly to Fiji and then back down, or go to Hawaii and go back down, because there is no plane in Kiribati big enough to make that 2,000-mile trip and then turn around and make it back again. So you just sort of get the scale and sense of the problem. So working with Google and working with Oceana, a conservation organization, came up with a really ingenious approach to track fish using their transponders. So this is what it looks like in Kiribati. On the left is the Phoenix Island Protected Area before it was declared off limits to tuna fisheries. And on the right, it's the same area after it was declared off limits to tuna fisheries. You can see the intensity of fishing that goes on in these areas for tuna. And you can also see that this protected area, for the most part, has worked. Last year, the end of last year, a fishing vessel actually went in there and illegally was catching fish. And they found the track. It was doing these big loops, and they knew exactly what they were doing, which is putting down seine nets for tuna. And they used those tracking data to basically interdict the boat and stop prosecution on it. The owner of the boat, realizing that the game was up, paid a $2 million fine to the government of Kiribati in order to have the ship released. These are big, big ships that are mostly coming from Europe or coming from Asia. So this gives you a sense of how science is starting to unravel the oceans. We're getting better at understanding where fish live and fish go. We're also getting better at understanding where fishermen live and fishermen go. The second part of what I told you about science, now science is great for revealing things, but then you still need people and communities in order to make things happen. So now I want to take you to a place that if any of you ever have a chance to do that one trip of a lifetime, this is the place to go. And you care about the oceans, this is the place to go. It's called Raja Ampat. Raja Ampat is out here, let's see if I can get this. So there is Papua New Guinea, here in Jaya, right? You can see that. This is in Indonesia. And Raja Ampat is off the bird's head of Papua New Guinea. It's sort of on that tip there, that circle out there. And why it's so extraordinary is it's a place where loads of currents meet. The Indian Ocean and the Pacific Ocean are mixing there. And as a result, you basically have the highest diversity of coral, soft coral on the planet. You also have the highest diversity of fish on the planet, over 1,000 species of fish, and they're finding new ones all the time. So it's hard to get to. It takes about 4 flights in a boat. But when you go there, the diving is superlative. It's like nothing else you've seen in your life. I first went to Raja Ampat about 12 years ago. And it was amazing in terms of coral reefs, but in the 6 days or so that I dove every day continuously, I only had one dive where I encountered sharks. Today, if you go there, virtually every dive you will run into sharks and mantas because the populations have really recovered. It's also a really interesting place where 3 big conservation groups, the Nature Conservancy, World Wildlife Fund, and my group, Conservation International, have all worked together over a period of decade to really bring about conservation and protection to this region. The key in Raja Ampat, and I'm just going to show you a 1-minute sort of beauty shots of Raja Ampat because it's so pretty that you kind of need to see what it looks like, and then I'll tell you what I think is the key to saving it. the sense of what Raja Ampat is all about. The trick with Raja Ampat, what really happened there is that conservation organizations went there, got to know the communities, and really tapped into a traditional form of fisheries management. It's called the SASI system. And they got into this and they trained people to then spread that traditional form of management to other islands and other communities. And basically, one by one, communities started establishing protected areas, marine protected areas, with community rules and guidance about how to protect it. And it was really interesting. If a protected area was out of sight of a community, it didn't tend to do really well. It had to be in sight of the village to really flourish. So we learned a lot, and over 12 years, it's really turned around. And these are sort of the results of it. Illegal fishing is almost non-existent, and you can detect this in lots of ways, blasting and things like that. Fish biomass has grown, coral cover has grown, and tourism has grown as well. And then sharks and manta rays and things like that, the big critters are back, and they're back to stay, and they're back in force. The other thing that was really, to me, really interesting about Raja Ampat was that the communities really had always really strong traditions, but it had sort of been broken down. And so all we did was sort of give them that push to do it. And it's worked so well that today, if you go as a tourist, if you go and live on a liveaboard and go diving there, you have to pay a fee. You pay $100 and you get a little metal tag. That $100 allows you to dive in Raja Ampat. Now here's what's amazing. Every cent of that money goes back into conservation into that community. It's the only protected area system in all of Indonesia where the money doesn't go to the central government. It'd be like going to Yosemite, paying your park fee, and knowing that the money just stays in Yosemite. It's a remarkable thing, and it took us a long time to get us to that stage. But that's what now gives the fuel that we need in order to continue to protect it, where the conservation groups are doing less and the community is doing a lot more. So if you can go to this place, you should. It's pretty amazing. So Raja Ampat's a great place, and we're on the way to protecting it. But how do you really scale this up? So I told you the real trick is to think about businesses. So quick question for you. How many of you shop at Whole Foods? Is there one nearby here? There must be one here. All right. Is there a Walmart here? No. Okay. So here's something that's going to amaze you. So I go to Whole Foods as well when I'm in D.C. It's kind of funny, every time you go into Whole Foods, you spend $140. Have you ever noticed that? Doesn't matter what you go for. You can go for lunch, you can go for a party, you can go. It's always $140. It's kind of like this magical number, right? So you go in there, it's kind of spendy. It's a beautiful store, and I'm not knocking it. I'm just impressed at what they've managed to do and how they've turned the people onto eating healthy and eating right. But fish is something you can buy there, and it's expensive fish. If you go to Walmart, the big Walmart stores, they too have fish. And here's the thing that might shock you. It turns out that the fish that you buy at Whole Foods is certified using a very high standard of certification called the Marine Stewardship Council. If you go there, look at it, you'll see it says MSC certified. If you go to Walmart and buy fish, it's the same certification. It's MSC certified. Think about that. Walmart and Whole Foods are using the same level of certification for fish. Now, why is that? It turns out that they do it for two different reasons. And this is the thing that I think is sort of most exciting about the world we live in today, living on a planet with 7 billion people. When I was in grad school, we wanted to be environmentalists. So we'd go out and pay the extra dollar to buy like a Patagonia outfit, right? And we'd wear it, and it'd be kind of cool, and we knew we'd wear it with pride. And we weren't shy, and we weren't afraid of spending a little extra in order to support something good. Today, it's really turned around. Today, the really big companies are in on the act. They're in on the act not because they want to differentiate themselves from the market. They're in on the act for a very, very simple reason. If Walmart doesn't certify its fish as sustainable, they will run out of fish. When you have 11,700 stores around the planet, and you're the biggest retailer out there, and you want to serve fish, you better make sure you know that the fish that you're getting is going to be there forever. Now, the funny thing about this is that Walmart doesn't advertise this as such. You'll almost not figure it out. You'll go and you'll have to look really carefully, and then you'll see the MSC label. So if I asked them this, why don't you talk about this more? And guess why? It's because they're worried that people might equate sustainability with a higher price. Walmart's whole business proposition is value for your dollar. And people think that if you're going for sustainability, it must be more expensive. Starbucks does the same thing. So CI's worked with Starbucks for decades. By the way, you know McDonald's, the McFish sandwich? That was the first thing CI actually worked on. The McFish sandwich that you buy at McDonald's, it's also MSC certified, right? You go to Starbucks, every ounce of coffee Starbucks sell comes from a sustainable supply chain, 400 million pounds of coffee. It's for the same reason. Today, for big companies, sustainability equals availability. And for me, that's, I think, the tipping point. If we can take great science in order to understand the world and figure out where things go and how they move and how they breed and where they live, figure out how we use those resources, and then work with communities to find real local voices who will say, this is important, I'm going to protect it. And then tie that to a supply chain. Then you can really scale a big idea. And then, frankly, governments will really take notice. So for me, that's the sort of holy trinity of aligning those three things. Science for discovery, people to anchor, and then businesses to help you scale. So with that, I kind of want to end with one last sort of story. And it's a political story, and I had to do this because guess what? I think, aren't they all showing up here on Saturday? I'm told Burlingame, and I'm like, God, that's near the airport. I got to get out of here quickly. I live in Montana most of the time, and we're blissfully unaware of most of these things. But I wanted to end with sort of a little bit of a political story, because there's one other point about conservation that I think is really important. It's important for this audience in particular. Does anyone know who this is? Real political buffs here. Come on. It's Garfield. Does it say that? Wow, very good. You get a prize. You get to swim with the sharks today. So that's President Garfield. And President Garfield is kind of unusual because he's one of the three presidents who were assassinated in office. We don't know much about him except for the street or the cat. And he doesn't live very long. He's after the Civil War. And had he lived, he was a very unusual guy. He came from the House of Representatives. He was a Republican. It was a brokered convention. He did not want to be president. They had to basically force him to do it, unlike the current lot. And he stepped in very reluctantly to take on the presidency. And he had very progressive ideas about the reconstruction of the South. Had he lived, it is possible that the civil rights movement might have had a very different flavor, because he was very progressive about what freed men ought to actually experience and have, and how their lives should be lived. But he doesn't live, because 70 days into office, he's shot at a railroad station while he was making his way from D.C. to Pennsylvania, and he's lying on the floor bleeding. And as he's lying there, his aide is looking for someone to help him, and he sees this doctor. By the way, the aide is Lincoln's son, Todd Lincoln. And this poor guy is actually by the side of three presidents who get killed in office, right? Because he's also on the side of Mackenzie, who gets shot in office. So just think about this kid and the therapy that he must have had to deal with. So Garfield is lying there, and Todd looks up, and he sees this doctor, and as he's looking, a young doctor walks up and says, "Don't touch him. Let's move him to a clean place. Let's keep the wound clean, and don't touch the wound, whatever you do." So he's sort of saying this, and he's trying to take control of the situation, a young doctor, and Todd sort of ignores him and sees this very, very famous surgeon walking through, a surgeon who actually attended his dad when Lincoln was shot. And he goes up and calls this older surgeon with his big white beard, and he wears a lab coat that is so covered in blood that it's black. It cracks with blood when he moves around. And this guy's name, by the way, is Doctor. Like, his real name is Doctor. It's actually Dr. Bliss. So he's Dr. Bliss, right? So he goes, "Doctor, Doctor." You got to say it twice when he's named Doctor. And so Dr. Bliss, you can't make this up, it's a true story. So Dr. Bliss comes over, and he kneels down, and the first thing he does is he probes the wound trying to find the bullet. He does it with his fingers, long fingernails, and he introduces an infection. Doctors do this over a course of some weeks, and poor Garfield, 100 or so days later, dies. And they pull out pus from him, 2 pints of it. It turns out the bullet didn't do anything. It was, bounced off a rib and broke something, but that was it. He didn't die from that. He died from the infection. Now, why I tell you this is the young guy who came and said, "Don't touch this guy," had studied in Europe and had learned something called the antiseptic method, which is these tiny little things called germs that were around and floating around the place that was everywhere and that could kill you. What a crazy idea. And he had studied under a guy named Lister, who, talked about carbolic soap and washing your hands and all of that. But he was ignored. He was ignored because his ideas were a little crazy, and if he had been listened to, and 10 years later, America had now adopted those standards, Garfield would have lived and it would have changed the course of this country. He was also probably ignored because he was black. He was one of the first black surgeons in the Union Army. He was young, he was different, he had crazy ideas. I tell you this story because it's really important to think about the message, but it's also really important to think about the messenger. And in conservation and conservation science, one of the things we do really badly is we conflate the two. We think if we're really smart and give you all the data, you will make rational decisions. It turns out you will most likely listen to people just like yourselves. And that's why I kind of need all of you. We all need all of you. Because there are some audiences that I can go to and have a big impact. And there are some audiences you can go to and have a big impact. And that's where the power comes in. So my feeling is we're going to all sink or swim together. And I really want all of you to embrace this. Embrace the idea of science as exploration. Embrace the idea of working with communities to make conservation work. And then think about scaling it. And think about talking to folks who you know, your friends, your colleagues, and encourage them to learn about the natural world and what's happening to it. So before I end, I want to show you one last little film. And this is a film that we made, Conservation International made. And we made a series of films called Nature is Speaking. And it was a way of giving a voice to nature, asking nature, what would you say if you could come and speak to all of you? And what does nature say? Nature says, guess what? You know, you need me way more than I need you. Nature makes the point that you are all part of nature, so saving it should be in your own enlightened self-interest. This film, we've made a series of 10 or 11 films now. The first one was done by one of our board members, Harrison Ford. It's called The Ocean. And this one is one of the more recent ones. And we took this to Paris at the climate conference in Paris and showed it there. And it had a really profound impact because it reminded the delegates in the Blue Zone that nature too was at the table. It's narrated by, in French by Marion Cotillard, who was an Academy Award winner, and in English by Reese Witherspoon.
I am home. I give you comfort. I shelter your family. See me for who I am. Home, sweet home. I am your refuge. I am the floor that supports you, the foundation that keeps you steady, the walls that give you shelter, the roof that protects you. I am your home. If you don't take care of me, I cannot take care of you.
Look, I think we're in a really incredible moment in time right now. We're the first generation that can actually see what's around the corner. We can see the whole planet. We can see underwater. We know what's coming. 50 years ago, we didn't know that. 20 years from now, it'll probably be too late. We really will hit tipping points. So if you're in this game, now is the time to be in it. Now is the time not to sit this one out. We know what's heading our way. The question is, do we all swim or do we all sink? And my proposition is we ought to swim and we ought to do it together. Thank you so much for being here tonight.